Hello again. This is section 1.1, modeling with area. And we are going to learn how to use area formulas to solve problems and also how to use surface area formulas to solve problems. One of the formulas that we're going to be using is population density. The population density of an area is a measure of how many people live within a given area. And it doesn't necessarily have to be people. It could be insects or flowers, or this crosses a lot of different spans of study. So, it doesn't have to be, it just depends on population of what. So population density equals the population of whatever you're trying to find over the area that these things are in. So in the first couple examples we have population density of people, but make sure you know this formula. So you must know this formula. Population density equals population over area. There's another tool that I had given to my students in the past with this, and it's this triangle. Picture kind of thing, and the population density would go in this first corner here, equals the population over the area. We're going to do the same formula when we get to the next section and we have density equals mass over volume. But this triangle kind of helps because when you're looking at this formula, depending on what you're trying to find, if you're trying to find your population density, you take the population divided by the area. If you're trying to find the area and you're given a population and a population density, the area is going to equal the population over the divided by the population density. If you're trying to find population, then the population is the population density times the area. So just to review that again. So PD equals P over A, which is exactly what we have here. But if you're trying to find the population, you would take the population density times the area. If you're trying to find the area, you would take the population divided by the population density. So just other ways of rewriting the formula to fit what it is that you're trying to find. But having that little triangle reference I've found has been helpful. Okay, so now that we got our formulas, let's see what we're trying to find. We are finding a population density. So step number one, it says the state of Colorado has a population, so they're telling us the population of Colorado is about 5 million people. They want us to find the population density in people per square mile. So our answer always has to have the correct unit of measure. So units of measure are going to be really important in this chapter. So we're trying to find the population density in people per square mile. And they also tell us a bit about Colorado. They tell us that the area of Colorado, or they tell us the shape that Colorado is shaped like a rectangle and has dimensions of 375 miles by 275 miles. So it's rectangular in shape, and its length and width are 275 miles and 375 miles by 275 miles, which when you multiply miles times miles, you're going to get your miles, square miles. So looking at our units of measure, everything is in miles, so we don't have to do any conversions yet. But they are telling us 5 million people. This is a number that's written in words that you are going to have to sometimes write in regular numbers terms. So when you see 5 million or 6.5 million or 3.2 million, you basically want to take that number times 1 million. So 5 million is a really easy one to figure out because it's just 5 with the 6 zeros after it. But if you had a decimal like 5.2 million, you'd want to take that number, whatever the number is, whether it be a whole number or decimal, multiplied by 1 million. whoops, I'm doing this wrong. So 1 million is 1 with 6 zeros. So if I take 5 times 1 million, I'm going to get 5 million. But I'm not going to need that quite yet. The first thing I want to do, so when you're finding the population density, you're going to take the population divided by the area. Well, in the information, it doesn't tell us directly what the area is. So when we're finding the population density, we're going to take our population, 5 million, and we have to divide it by the area. So you might want to find the area first. So the area of Colorado is going to equal 375 miles times 275 miles. So when we plug that in our calculator, 375 times 275, I get 103,125. So 103,125 square miles. And again, units of measure are important, so write them down. Our 5 million, what did our 5 million represent? People. So we've got 5 million people. That's our population. And then the area that we just found was 103,125 square miles. Now we're going to divide because we want to find how many people we want the population density in people per square mile. So we want to know how many people are in 1 square mile. So we're going to divide our 5 million by the 103,025. So going to my calculator, make sure you are exact and precise with your calculations. Make sure that there are 6 zeros. And then divided by 103,125. Now when you're rounding, you do not want a partial person. So we're going to round to the nearest whole person. So in this case, it would be 48 since there's a 4 after the decimal. So we're going to say that the population density is approximately 48 people per square mile. I'll just put 48 people per square mile. If you were to write it as a sentence, I would say the population, let me zoom out here, the population density of Colorado is approximately 48 people per square mile. So that would be a nice answer if this was a standardized test or a test or quiz, because that explains exactly what we're finding the population density of. All right, so hopefully you can do the homework problems like that on your own. Moving on to example 2. We're going to use the population density, but we're going to use the formula for population density, but we're not going to actually be finding a population density this time. So let's read what we're doing. They're giving us information. They're telling it's a circular region. So we basically have a region that's in the shape of a circle. And they're telling us there are about 21,400 people in this circular region. So 21,400 people in the circular region. And they're telling us it has a population density of about 425 people per square mile. So they're telling you the population, and they're telling you the population density. So what are we trying to find? You are trying to find the radius of the region. So the radius is part of the formula for area. Well, since you're given you're told that it's a circular region, you are going to have to use your circle formula. So there's a couple ways you can do this. You could use the population density formula and say, so population density equals population over area. Again, the more you write it, the easier it will be to remember. So your population density is 425 equals the population, which was the 21,400, divided by the area. Well, we don't know what the area is. The only thing we do know about the area is that it's a circular region. So the area of a circle is equal to pi r squared. So we can put pi r squared down here. And now our problem is, how do we solve for r? Well, r is in the denominator right now. So sometimes when you're trying to solve for variables that are in the denominator, it may be easiest to multiply both sides of the equation by that denominator to get it out of the denominator. So if I multiply both sides of my equation by pi r squared, that will get that pi r squared out of the denominator. So when I rewrite my equation, all of these things are being multiplied together. So I'm going to put the 425 in front, then the pi r squared. And that's going to equal my 21,400. Okay, so what do we do now? Well, still trying to get r by itself. Well, r is being multiplied by this 425 and this pi. So if I divide both sides now by both the 425 and the pi, that will eliminate the 425 pi, or reduce the left side. Okay, I'm going to use my space over here, rewrite my new equation. R squared equals 21,400 divided by, now this is where you definitely want to put parentheses around the 425 pi. People put this in the calculator all the time, and if they don't put parentheses around it, your calculator is going to divide the 21,400 by 425, and then it's going to multiply that value by pi, which is not what you want to do. It's going to give you the wrong value. So you want to make sure that your denominator is in parentheses. Okay, but we're not really ready to put this in the calculator yet anyway, because we don't want to know what r squared is. We want to know what r is. So to get r, you're now going to have to square root both sides of your equation. Okay, so this looks a little bit complicated. Now, normally when you take the square root of both sides of the equation, because it's an even root, you're going to have a positive and a negative answer. However, reasonably, your radius cannot be negative. So if we think about reasonable answers, we're only going to have a positive. We're only going to use the positive solution. All right, so what does square rooting do to the equation? Well, that gets rid of or undoes the square. So now we are ready to plug this in the calculator. And you do not want to plug it in the calculator until you get to this point. You want your answer to be as exact and precise as possible. And it doesn't really tell us what to round it to, so we are going to round it to the nearest whole number. All right, so let's see how we put this in the calculator. So I'm going to start out with my square root sign. Square root is above the x squared, hit second and then x squared. Again, it depends on what your calculator looks like. And then I'm going to plug in the 21,400 divided by, now your denominator must be in its own set of parentheses, 425 pi. and then I'll close the whole thing. So I've got two sets of parentheses. Oops, I forgot to write this one here. So if I highlight this, I've got a set of parentheses around the whole fraction, but I've also got a set of parentheses around the denominator. So let's just look back. If I show you what this whole thing looks like again, I've got my square root sign, and it automatically gives me the left parentheses, 21,400 divided by, and then in its own set of parentheses, I have the 425 pi, and then I close the big parentheses, and then I'm going to hit equals, and it rounds to 4. But for what? So we have to think about, what is our unit of measure? Well, let's look at what we were given before. The only units of measure that I see are people and people per square mile. So miles is what our radius is going to be in units of. So that's a distance. And we just did example 2a. Now, like I said earlier, there is another way that you can do this, but again, it involves knowing these formulas up here. So if you know, we're not necessarily looking for the area in this problem. We're looking for a piece of the area. We're looking for the radius, which is part of the area. So if you used this formula that's been modified rather than the population density formula, it may be a little easier to do the problem. Let's see. I'm just going to kind of do it off to the side over here, see if this will work. So my area would still be pi r squared. My population is 21,400. And my population density was 425. So area equals population divided by population density. So to get the r by itself, I would have to take this whole value and divide it by pi. Which would then give me r squared. So this looks a little complicated, but it would be 21,400 divided by 425 divided by pi. And then I would have to take the square root of that whole thing. So this is one that I might want to use the answer button. So there is a function on your calculator that's really important and very useful, and it's the ANS button, which means your previous answer. So what I'm going to do is I'm going to take the 21,400 divided by 425 and then divide that by pi. I'm going to hold it in the calculator, and then I'm going to take the square root of whatever that previous answer was. So, and again, it's only going to be the positive answer, not positive and negative. So let me show you what that looks like. So 21,400, divide that by your 425. So you can hit equals, or you can just hit divided by pi. So let me do that again without hitting equals between. So 21,400 divided by 425 divided by pi. Hit equals. So I get the same value, 16.02, blah, blah, blah. Leave it in your calculator. Do not round it. And then to get the square root of this number, I'm going to hit my second and my x squared so that I get the square root of, zoom out here a little bit so you can see the buttons. So that was a second and an x squared. And now I'm going to hit my second and the negative sign, which is down here, so that it says the square root of the previous answer. Then hit my equals, and again I get that 4.0034, which is the same thing as I had earlier. All right, so that's just another way of putting it in the calculator and solving it. All right, moving on to example B. So in example B, you are told that it's a circular region again. However, you're being also told that it has a radius of 3 kilometers. So they're telling you the radius this time rather than having you find it. But the circular region is important because that tells us that our area has to be pi r squared. Your radius, 3 kilometers. Now I am going to put the unit of measure in this time because I think it does kind of help sometimes when you have it in there. So when I simplify this, make sure that you square the 3, which is going to be 9, square the kilometers, which will be kilometers squared, and then you're multiplying that by pi. So when I rewrite this in regular terms, you want the 9 in front of the pi, but don't multiply by pi yet. So our area is 9 pi kilometers squared. Now let's see, what else do they give us? They give us the population is 70,000. And they want us to find population density in people per square kilometer. Okay, so looking at your units of measure, your radius was in kilometers. They want population density in terms of kilometers. So there's no conversions going on. We just need to take our formula for population density, which is population divided by the area, and then plug in our values. So our population is 70,000. Our area is 9, so that's people. And our area is 9 pi kilometers squared, or square kilometers. And again, I'm going to put parentheses around that 9 pi so that when I plug it in the calculator, I don't forget to put parentheses around it when I'm calculating. People have to be in terms of whole numbers. You cannot have a partial person. So we're going to take our 70,000 now in our calculator, divided by parentheses 9 pi. Close the parentheses. So that 9 pi, please, please, please put it in parentheses. And now we're going to round to the nearest whole person, 2,476. So it's approximately 2,476 people per kilometer squared or square kilometer. Make sure your units of measure are correct. So if you just were to 6. Okay, so this is the end of this problem. So we end up with 2,476 people per kilometer squared. Okay, next page. Okay, so in this example, we have a manufacturer that's designing a bearing that's shown. So this bearing over here is what we call the bearing shown. It's going to end up being the larger one, but we're going to call it the bearing shown. And a bearing is something that is in gears and things to machinery to help things move smoothly through a conveyor belt or something like that. So anyway, it's just a little rod of metal that's used in machinery. So this bearing is basically in the shape of a cylinder, and it has a radius of 2.5 millimeters and a height of 20 millimeters. So you can see I put those labels on the radius here at the top of the cylinder and the height of the cylinder. The directions say that to prevent corrosion, the manufacturer coats each bearing with anti-corrosive grease. So we're going to be covering this bearing with grease. It's also telling us a smaller bearing has linear dimensions. So the linear dimensions are basically your radius and your height. So linear dimensions are things that are a length. And it's telling us that the smaller bearing has linear dimensions, or radius and height, that are 1/2 the dimensions of the bearing shown. So again, they're using that bearing shown, which is the one that's in the picture. The question that they want us to answer is, does the smaller bearing require half or 1/2 the amount of grease that is used to coat the larger bearing? So if this was true, if it did take 1/2 of the amount of grease, then the surface area for the larger bearing and the surface area of the smaller bearing then should be half of the surface area of the larger bearing. So in order to answer this question properly, we need to find the surface area of both of these bearings. So the larger bearing is the bearing shown. And the smaller bearing is the one that is half the dimensions. So let's put the dimensions in our table here. So the dimensions for the larger bearing, the radius is 2.5 millimeters and the height is 20 millimeters. So if the smaller bearing is half the linear dimensions of the larger bearing, then all we have to do is basically cut those in half to get our new dimensions. So the radius, half of 2.5 is 1.25. And the height would be half of 20, which it would be 10 millimeters. Okay, so the next thing we need to figure out is, how do I find the surface area of a cylinder? Well, there's a formula for that, but it basically comes from you're finding the area of the two circles at the top and the bottom, and then the perimeter, which is basically the circumference of the circle, times the height. So the formula goes like this. It's 2 pi r squared plus 2 pi r h. So the pi r squared is what we're going to call big B, because that's the area of the base of our cylinder, which is the shape of a circle. And we have two of them, so it's 2 pi r squared. So that's big B, or the area of the base. And the 2 pi r is what we would call big P in a lot of formulas, where big P is usually the area of, the perimeter of the base. Well, but because we have a circle, the perimeter of a circle is basically the circumference. So capital P, or big P, is basically the perimeter of the base. And then we multiply by our height. So this is our formula. Hopefully you understand it a little bit, but we're going to plug these numbers in. So 2 pi r squared plus 2 pi r h. And I like to use parentheses when I'm substituting. So the 2.5 millimeters is what I'm going to substitute here and here, because that's my radius, and then I'm going to substitute the 20 for my height. Now when I'm calculating, I want exact values, so I'm going to leave these numbers in terms of pi, which means I'm only going to multiply the 2 with the 2.5 squared. So when I do multiply 2 times 2.5 squared, I get 12.5. And then since I did not multiply the pi in, it's just going to tag along after it. So this expression, when I simplify it, should be 12.5 squared. But try that on your calculator. Make sure you're getting the same value. And then over here, this expression, the 2 times the 2.5 times the 20 is going to be 100, because 2 times 2.5 is 5. 5 times 20 is 100. And then the pi again. And now we can add these together because they're like terms. They both have a pi. So the surface area of this larger bearing, or the bearing shown, when I add those together, is going to be 112.5 pi. And then since it's area and we have millimeters, your units of measure would be millimeters squared. Okay, so that is the surface area of the larger one, or the bearing shown. Well, now we need to find the surface area of the smaller bearing. So again, we're going to use the same formula, 2 pi r squared plus 2 pi r h. But this time I'm going to be substituting my smaller dimensions, 1.25 1.25, and 10, which were half of the other dimensions. So now when I multiply that 2 times that 1.25 squared, let me get my calculator out here, 2 times 1.25 squared, and it's just going to look like this in case you need to see what your calculator should look like. So when I do that, I hit my equals, I get 3.125. And again, I want to be exact, so I'm going to write that exact value, 3.125. I did not multiply the pi in, so I'm just going to say 3.125 pi plus, and then multiply your 2 times the 1.25 times 10. 2 times 1.25 times 10, and I get 25 pi. Again, those are like terms, so when I add them together, I will get 28.125 pi millimeters squared. So that is the surface area of the smaller bearing. Now that we have the surface area for each one, we can compare them and ask ourselves, well, is the surface area of the smaller bearing half of the larger bearing? Well, no. Half of 112.5 would be something like 56, so 0.25, where this is a lot more than that, so, or a lot less than that. So no, it is not half. So then it wants us to explain, well, how much smaller is it? So the first question that we can answer is no. So explain why. So we are going to figure out we want to answer this question or fill in these blanks. The surface area of the smaller bearing is how many times the surface area of the larger bearing. So when you're trying to compare the smaller one to the larger one, we're going to set up a ratio. And when you do the ratio for a lot of these problems, it's going to be the new dimensions over the original. So the new dimensions would be the smaller one after we cut the dimensions in half, so 28.125 pi over the original, which was 112.5 pi. And then we're going to reduce this. Well, if you notice, they both have a pi, so we can reduce the pi's, and then we can divide the 28.125 by the 112.5, and we get 0.25, which is equal to 1/4. So the surface area of the smaller bearing is actually 1/4 times the surface area of the larger bearing. So the smaller bearing requires 1/4 of the amount of the grease that is used to coat the larger bearing. All right, so this part B now is a continuation of the previous part. So this is a lot of stuff to this problem, steps to this problem, but they're saying now a different smaller bearing. So this is a new smaller bearing, different than the one that we had in the last, in part A, has the same radius and a height that is 1/2 the height of the bearing shown. So again, that bearing shown is the original, this one here that had the 112.5 pi. But it's going to have the same radius as the original. It's only the height that's going to be cut in half. So same radius. So the radius of this new small bearing is going to be 2.5 millimeters, just like the original one. But the height is going to be 1/2 of the height of the bearing shown. So our new height is going to be 10 millimeters. So it's just the height that's changing, not the radius. We still are going to use the same formula because, again, we're going to want to compare. The question is 1/2 the amount of anti-corrosive grease used to coat the larger bearing enough to coat this bearing, so this new one? Yes or no, and explain why. So in order to answer that question, we need to, again, find the surface area of this new bearing. So we're going to use the same formula, 2 pi r squared plus 2 pi r, whoops, I'm going to put a number in there, r h. All right, so now we're going to plug in our values. The radius was 2.5, and the radius here again is 2.5, but the height is only 10. Well, we already calculated this in part A, right here we've got 2 pi times 2.5 squared, and that gave us 12.5 pi. So we can just carry that down, 12.5 pi, instead of having to calculate it all over again. And then this part here, if I multiply the 2 times the 2.5, that gives me 5 times 10 would be 50 pi. So when I add that together now, the surface area of this new smaller bearing is going to be 62.5 pi millimeters squared. And now we want to compare our new one to the original. So again, we're going to set up a ratio. So the ratio of the new over the original. So the new surface area was 62.5 pi. My original was 112.5 pi. And when I reduce the pi, that's nice, we can get rid of that. And then when I divide this, I do get 0.5 repeating. So if I want to put, rather than saying 0.5 repeating times the surface area of the, so in the next part here when I'm filling in these blanks, I don't want to use 0.5 repeating. I would like to change that to a fraction. Well, 0.5 repeating actually is 5/9. Whenever you have a repeating decimal, just put that number that's repeating over 9 if it's one digit, and that will be your fraction. Or you could, on your calculator, if I type in the 62.5 divided by 112.5, and that's what it looks like on the calculator. But if I want to change that to a fraction, and if I have something I don't know how to change to a fraction, or even if it will, hit your second and then the PRB button. So this is telling us it's going to take the previous answer and change it from a fraction to a decimal or decimal to a fraction, whichever it's given. So then I hit my equals, and we can see again that it's 5/9. So our fraction is 5/9, and that's what we're going to put in our sentence here. So the surface area of the smaller bearing is 5/9 times the surface area of the larger bearing. So now we have to figure out, well, is 5/9, since this new bearing is 5/9 of the original, is 1/2 of the amount of grease used for the larger bearing going to be enough to coat this smaller bearing? Well, actually the answer to the question would be no. So, but I'm going to put that in here because 5/9 actually is greater than 1/2. 0.5 repeating is going to be greater than 0.5. So that new bearing is bigger than half. So if all I have is half of the amount of grease, it's not going to cover the 5/9. So since 5/9 is greater than 1/2, 1/2 of the amount of anti-corrosive grease used to coat the larger bearing is not, so we would say is not enough to coat the smaller bearing. And that's the end of lesson 1.1.